this moment. Location. Fortunately, with a mobile device, you can track user location very effectively and provide user services based on the location. Now, on a PC or on a computer, you do realize that location tracking is not a big issue. I mean, most laptops are not equipped with GPS and so on. But then obviously, you don't expect somebody to be carrying their laptop fully on and walking around on the streets with the laptops on and with the screens open and so on. It's dangerous, first of all, and secondly, it is stupid. Okay, but mobile devices are tiny, easily portable, and in your pockets or in your purses, and they go from place to place, and they are always on. So obviously, it makes a lot of sense for your mobile device to keep track of your location. How many of you realize that even browsers, like for example, if you do a Google search based upon your location, the results returned are different? Right? If you do the same search, for example, in Hong Kong, as opposed to if you do the same search, say, for example, in Cupertino, well, Cupertino just came to my mind because of Apple. Cupertino, your answers returned by Google will be different. So obviously, some sort of location tracking is taking place. I mean, that is done based upon your IP address of your device, and your IP address sort of approximately gives the company some knowledge of where you are located at the moment. Now, location can be very effectively used to provide very good services to users. So that's the reason why we learn how to make user location and then how to provide services based upon the location. So location-aware applications and maps-enabled applications are becoming very popular on most mobile devices. Now, I have to make it very clear to you that location and maps are not one and the same. Many people have confusion in their mind, thinking that location requires maps and maps requires location. The two are completely orthogonal to each other, as I will talk to you in a short while. Okay? Google Maps is one of those services that enable you to provide maps-based user interface. Google Maps is not the only way of doing it. You can do it in other ways if you want. But fortunately, Google Maps it provides a very intuitive map interface. You can use other things like OpenStreetMap, Bing Maps, and other things to provide similar services if you want. But on an Android device, because Android is very much supported by Google, Google does support Google Maps interface for Android. But you have to remember, again, I'll make it more clearer when we discuss Google Maps specifically later on, the Maps interface specifically later on. But again, to remind you, location and maps are two separate things. They have nothing to do with each other. You can design a wonderful maps-based application without using the user's location. You can provide wonderful location-based services without ever using maps. That's something that you need to keep clear in your mind. Now, the question now boils down to how do you find the user's location? How can the user's location be specified? On Earth, every point on Earth has a unique location information associated with it. In your high school geography, or maybe earlier, you have learned about latitudes and longitudes, right? And you know that latitudes and longitudes are these lines that are drawn on Earth. Well, not literally drawn on Earth. These are conceptually existing there. So if you go looking for the latitude in Hong Kong, you won't find a line drawn there. Or how many of you in your primary school, when you were told about equator and Tropic of Cancer and Tropic of Capricorn, you thought that if you go to a place, you would find the equator as a line drawn there? You know, as children, we have the strange imagination in our head. If that were the case, in Singapore, you would have an equator drawn right in the middle of Singapore, right? or Singapore is, I think, still a little bit north of the equator, if I remember. But when we pictured these things in atlases, we always saw a line, typically in blue color, drawn across the map. Obviously, this is only a conceptual thing that exists there. But fortunately, this specification gives us a very unique way of specifying each and every point on Earth. Because each and every point on Earth has a latitude and longitude information associated with it. So, if you can pinpoint a device's latitude and longitude, you know exactly where it is on Earth. Okay? Now, depending upon the different kinds of services through which you can extract your location information, all that you will be interested in is knowing your current latitude and longitude position, plus perhaps the current time, UTC time. You all know what UTC is, Universal Time Control, which is based upon the GMT. So that's the time at this moment you want to know. In addition, you may be able to even get additional information from your location services provider in the form of, for example, altitude, speed, and bearing. So you might even know at what height you are located from the sea level, if that is possible to know. Speed, that is how fast you are moving in case you're moving, and which direction you're moving. Because all these can be very effectively used to tailor applications to provide services to the user. If you know that the user is walking along Causeway Bay, you know Causeway Bay very well. If you imagine a user walking along Queen's Road, Central, I know Queen's Road Central much better, from Marks and Spencer, if you know Marks and Spencer and Queen's Road Central, and then you're walking westward, then as you walk westward, at some point in time, an app that uses your information could trigger saying, hey, there are this bunch of bars located here, you can go and have a drink, right? You know what I'm talking about. And then they could even deliver you things like coupons, free drink coupons for the bars, get your first beer free, and then after you drink your first beer, you'll be addicted and you'll drink 10 more beers, and so on, so forth. So that kind of additional information will be very useful for the device. Navigation purposes, like if you are using your device as a navigation aid and you're using it in your car, it could even tell you as you're driving along, it can even show you the current position on the map and then moving along and so forth. All right. Now, getting back to Android itself, how does Android provide you with the ability to make use of the user location? Obviously, you don't need to write the software that processes the GPS information in order to determine your location. That is already provided within the framework and your device. Similarly, network-based location, all that is already calculated. And Android, fortunately, provides you access to this information through certain capabilities, which I will talk about. I will talk you through the exact mechanisms whereby you can make use of this information. All these are provided through this package in Android, Android.location package. Okay. So if you import this package into your code, then you have access to this. Okay. But Google Maps based things is not part of Android. I will explain that when I talk about Google Maps later. The distinction between Google Maps and Android specifically. Okay? So the location framework within Android is based around this thing called as the Location Manager. Okay? Location Manager is a system service that enables you to get access to location information within the device. Android fortunately has many such kinds of system services that are available. You will encounter Location Manager here. Later on, we'll encounter something called Sensor Manager, which allows you to get sensor information from the sensors that are part of your device and notification manager, and so on. So Android fortunately compartmentalizes these things into different kinds of system service managers. So if you're looking for a particular kind of information to be delivered from your Android device, if you're trying to extract, look and see if there is a corresponding manager available to you. This manager will make a certain set of methods available to you through which you can acquire this information. So these managers provide the APIs for you. So the location manager, for example, provides the API for you so that you can query the location manager saying, tell me my current location. Tell me which direction am I headed at this moment. Tell me when I reach within a certain region of this particular location, what is called as proximity, and so on. So all these features are available through Location Manager. Okay? Now, so if you need to get this information, first and foremost, you need to get a handle to the Location Manager in Android. So in the code, you will declare a handle called as a Location Manager, and then you will say get system service Location Manager, and then you will return a handle. After you get a handle to the Location Manager, then you can invoke the methods of the Location Manager in order to get information. You can get information from the Location Manager, including things like querying for the last known user's location, which was the last point where you can accurately pinpoint where the user was at this moment. Second, you can register with the Location Manager saying, if the user is changing the location, periodically update me about the changes of the user's location. That could be very useful to find out the movement of the user. Okay? Maybe a navigation application can effectively make use of it. So in a navigation application, you could pinpoint as the user is moving along the road, for example. So that would be very useful. The third one, called as proximity, which basically says if the user is within a certain region or a particular location, then do something for me. Tell me that the user is within this radius of this particular location. And that can be very effectively used again to provide interesting services. There are a lot of applications that make use of these two. Proximity-based applications are becoming more common these days, and they are very, very useful. Indeed, we have developed a couple of applications that make use of proximity specifically for certain interesting uses. In fact, in the lab next week, not next week after, because next week is a holiday, so the week after when you go to the lab, you will see an application which I briefly showed you last time when I demonstrated the database aspect of it. We make use of the proximity in order to provide some interesting features within the application. So, within Android, first and foremost, how do you get to know the user's location? For that, you need to get hold of Location Manager and register with the Location Manager in order to ask to be updated about the user's location. First step, you get a reference to the Location Manager within the Android system. Okay? And then you can define something called a listener that will respond to location updates. So that when the Location Manager delivers to you saying, this is the latest update for the user's location, then it will invoke a listener that you can include within your application. And when that is triggered, then you are informed about this fact, and then you can do certain operations based upon it. And then you register the listener with the Location Manager. I'll show you the code for doing this in practice. Now, not only these, if you're making use of Waze, you need to also declare within the Android's manifest file saying I need access to the user's location. So within the manifest file, you need to include this particular statement. Android permissions access find location. If you include this statement within your application, then obviously when the user invokes your application, the user is reminded of the fact that this application is making use of your location information. So please be aware of this. You can do access find location. This makes use of GPS to finally pinpoint your location. You can say access course location. The course location makes use of primarily the network-based approach for pinpointing the user's location. So obviously, as the naming indicates, this is an approximation of the user's location. This is a lot more accurate. If you don't need such an accurate location of the user, then course location would be more than sufficient to satisfy your needs. And obviously, this would be less power hungry to use than that within your app. So when you make use of location within your app, keep in mind which kind of level of accuracy do you really need within your app. Now, code. See, every time I explain something, I throw in a bunch of code there to tell you how to make use of it. This is part of code extracted from somewhere, from one of the applications, to illustrate to you how to do those steps that I just showed you earlier in the previous slide. This is how you get access to the location manager, the handle to the location manager, reference. So you declare location manager, this get system service, context location service. Then this is a reference to the location manager. Subsequently, you can trigger a lot of methods that the location manager class makes available to you. Okay? Once you have done that, what is the second part that you need? You need to inform the location manager saying, when the location changes, please let me know. And for that, you need to register a listener. When you register a listener, what are you informing the location manager? Saying, if the location changes, call this listener. So that's why you're supplying the code here. So you're saying location listener, and then you declare. Now inside, I'm just indicating a function call, but this is actually a representation of what you would do if you were informed by the location manager of the current user's location. How are you going to make use of it? That has to be inside the location listener. Okay? That might trigger, for example, an update of the screen. If you're using it for navigation, it might trigger an update of the screen by repositioning an icon that indicates your current location on a map. If it is an app that lists all the restaurants that are nearby within a certain parameter of your location, then it might update the screen to indicate a new selection of restaurants. As you move, you will be updated with a new selection of restaurants, and so on. Or anything else, depending on what you're trying to make use of. Okay? Now, this together with it, you have certain other methods that you need to declare inside the location listener. This is one method on location changed, on status changed, on provider enabled, and on provider disabled. Now, obviously, this is very clear. Whenever there is a change of user's location, then this one will be triggered. This, whenever there is a change in the status of the device, this one will be called whenever the location provider is enabled. So for example, if you don't have GPS turned on but later on turn on GPS, then this will be invoked to say GPS is now turned on, and so you can receive updates. And similarly, if the thing is disabled, then that will be called and so on. But for your purposes, you can, if you want, you can just simply put blank in there. If you're not going to make use of that information, you can just leave it blank. After that, you need to register this listener. So you register the listener by calling the location manager. And when you do that, you need to provide which particular provider you're going to make use of for determining the location. So if you, in this case, if you indicate network provider, so you're informing this Android system saying, I just need your updates that you obtain by using network provider, which is obviously less power hungry. If you want fine location to be determined, you can provide GPS provider in this place here, and which indicates to the Android system saying, look, I need you to update me based upon GPS because I need a fine location of the user. You can simultaneously register listeners for both if you want, for both fine and coarse grained updates and so on. So this indicates which provider you're going to make use of. Are you going to use the GPS provider, or are you going to make use of the network?
So what do you write if you make use of both?
You need to do two.
Oh.
Network provider and GPS provider. So that way you are indicating. If you can use the same listener for both if you want. There's no specific reason why you need to have two separate listeners either. Obviously, it makes sense if you only need coarse grained, then this is more than sufficient. You should not be invoking the GPS provider as far as possible. Again, because to save power. Okay? Now, in your application, if you are making use of GPS within your application, how do you use it and how do you take advantage of it? Within your application, the moment you start your application, you get a reference to the location manager, and then subsequently you start listening for updates. And then any time there is an update, then you will make use of the update in order to trigger certain changes within your application. Okay. You at any given point of time within your app, you can maintain a current best estimate of the location. So you might be receiving, like if you register a listener both for the network provider and the GPS provider, sometimes the network provider's estimate might be delivered to you, sometimes the GPS provider's estimate may be delivered to you. As you realize, the GPS provider's estimate will have certain latency, but if you want a quick fix, for example, you may be happy to start out with a network provider, or even better, you can query the location manager saying, get last known location. If the device stores the last best known location, then you would be happy to start by working with it, and then subsequently be updated from the user's perspective. So if you look at how the application flows, obviously within your application you want to listen for updates for a certain period of time. After that point, if you don't need it anymore, turn off listening for updates. Because if you keep listening for updates, you will unnecessarily be causing the system to keep delivering updates. And so you can minimize updates by only listening for a while. So for example, as an example, when your application starts, your application goes through a certain amount of code execution, and then it starts and registers the listeners, and then it starts listening for updates. And as you go, perhaps at this point in time, the location manager just delivers the cached network location, the last known location, and you say, okay, you're willing to start off by using that information, and then subsequently maybe you want to discard that, you don't want it anymore, and then you continue on. After a period of time, perhaps you would receive a better estimate of the location by making use of the cell IDs. So you get this by using the network provider. This may be a bit more accurate, and say you are saying, okay, I will start working with that as my location. And subsequently, maybe you may get a further update from making use of Wi-Fi signals. And this may be a bit more accurate, and you say, okay, I'm happy with that. And then if, on the other hand, you realize that this one and this one are in total disagreement, you may decide to discard one of the updates, saying, look, I don't want to regard this, I'm going to throw that away. And subsequently, maybe you may get a more accurate, as you realize, GPS gives you a more fine, accurate estimate of your location. If you get that estimate, you say, okay, good, I got a pretty accurate estimate at this point. I'm quite happy with it. And then you may say, okay, that is good enough for me. Turn off my location tracking, and then I'm starting to deliver the services to the user. For example, if the location update says I am in this part of Central, and that is good enough for my application, so I say, okay, I got a good fix. I don't want to listen for updates anymore. I will deliver the content to the user, say for example a list of restaurants, and then I will just keep quiet for a few minutes. After a few minutes, maybe I will start listening for updates, because it's possible that the user has changed the location, so I want to update it. So you can minimize the amount of time that you want to listen for location updates. If you minimize the amount of time, you will consume less power from the device, because you are not needing frequent updates from the system. Yeah?
For the cached location, is it unique to the application, or is it universal to the phone?
It comes from the phone, as you see.
So if I use the location service, so
Yes.
all apps can
Start out by doing this first. You start out by asking for get last known location.
Does it kind of violates the
Privacy, well, yeah. It depends. Depends on what you're trying to make use of it for. If you have a private spy application that you've installed on the device, and you're trying to track whether the person carrying this is committing adultery or something like that, that's a different matter. But the device has the capability. That's the point that I'm trying to make. Device has the capability, and you can deal with it. Okay? So that's how you would make use of location. This is one possible way of illustrating how you make use of location. How do you save battery life and data exchange requirements? First, reduce the size of the listening window. So the shorter the time that you listen, the lesser the burden that you're putting on the device in order to find the location. Set the location providers to return updates less frequently. Okay? You can use the parameters that you supply for request location updates to indicate to the framework saying, update me about the user's location every 10 minutes. That is good enough for me. If the user is simply walking, in about 10 minutes you won't walk that far, even if you are a fast walker, right? So, the accuracy may be sufficient enough for you, so that's fine. So this is one way you can save on the battery life by not asking for frequent updates. You can do a third one by restricting the set of providers. Again, depending on accuracy, you can say, I don't want to use GPS, just provide me updates from the network location. That is good enough for me, for my application. So when you design your application, design it with the minimum requirement as far as possible, so that you don't tax too much of the battery life of your device. Okay? Now, suppose a user, for example, is doing content creation, like tweeting, saying, I am in Hong Kong. I'm in central Hong Kong. I'm looking up at this building or something like that. If you want to know where the user is, you may start beginning to listen for, or for the matter, if you take a picture, you know that all your devices nowadays have the ability to imprint the GPS location of the picture into the file itself. Now, for that purpose, for example, you can begin to listen for updates, and then once you get a fix, if the user is just taking a few pictures in that location, it's okay. Once you get a fix of the user's location, you can continue to use it for a period of time. Okay. So at that point, when the user has finished, stop listening for updates if the user is not making use of the application. So try and minimize the amount of time that you make use of the location updates. Okay. So that's one way that you can. So this is, for example, for geotagging user-created content like photos, like tweets, like videos and things like that. That's very useful in usage. Another scenario: location-based recommendations, like for restaurants or shops and things like that. Say, for example, when the application starts, user wants to see a set of nearby locations of interest. Say a tourist is visiting a place and wants to know what are the important tourist spots around the place that they are. Then the application listens for GPS and network updates. You estimate the location first, for example, based on the last known location, and then deliver a list. And then as you go along, the estimation is improved because maybe you got a network-based fix, which is a more accurate location. You can update the screen with a newer list, and then maybe you get a further update of the location, maybe by using GPS. You still update the screen one more time, and then at that point, maybe that is good enough. And as you keep updating, if you see that subsequent updates have not changed the screen a whole lot, then you say, okay, I seem to have delivered the most reasonable update to the user of based upon the location. There is not much of change that I see by querying my database. Fine, I'm done. And then you can stop listening for updates at that point. So one more place where you can very effectively make use of. These are all examples suggested by the Android people themselves, saying how you can make use of location information within your application. Okay. Now, in addition, the other thing that I talked about was proximity alert. Proximity alert is increasingly becoming more popularly used in devices. So, but there are not a whole lot of applications that are making use of this in practice. This might be a good target for new applications to make use of. One example that we thought of for proximity alerts was like you can design a tourist spot map of Hong Kong, and you can say, for example, the tourist wants to go to see the peak. You can set up a proximity alert for the peak, and as the tourist is going by, when the tourist nears the peak, the device will beep and say, oh, you are near the peak, so this is the peak, or something like that. Yeah? That's one possibility. Suppose you are traveling on the MTR, and usually when you travel on the MTR, what do? Especially if you're traveling long distance. You get into the MTR and then you sleep. And I have seen that happen very often. At any time of the day I go, people are sitting there like this. Either that or nowadays they are a lot more busy, they're playing around on the mobile phones. But I usually used to see people a lot more enjoying the traveling time by sleeping. But if you fall asleep deeply, then you may miss your stop, right? One possible application that you can develop is before the user falls asleep, they can set up a proximity alert for an MTR station and then put the device in their pocket. And as the train nears that station, the device will beep and then wake up the user, saying, "Oh, you need to get off the train at this point," and then make a hell lot of noise and then get there. Of course, that will also end up waking up your neighbors, that's a different matter. Okay? So, that's one place where you can very effectively make use of something called proximity alerts. This term, proximity alerts, is more commonly seen with, in use with Android. iOS has its own definition of this feature. The early versions of iOS do not have, but the later versions, more recent versions have something called zone or something like that. They define a region around a place. If you enter that region, then the alert is sounded. But basically, the idea is still the same. But in Android, it is called proximity alert in the documentation. Okay, so we'll talk about how we can make use of this in practice. How do you make use of proximity alert? You use the location manager. Location manager is the primary provider. He is the only provider of location-based information from the device. The location manager provides this particular method called add proximity alert. So we take advantage of that in order to set up proximity alert. Together with this, we also implement another one called as pending intent. This is an interesting thing you will see when I show you an example. This is an intent that will be activated at when certain conditions are satisfied. So you create the intent, but you don't fire the intent immediately. Instead, you say, when these conditions are satisfied, this intent should be fine, and you can specify it. And for proximity alerts, obviously something needs to be triggered. When something needs to be triggered, the component in Android that is very much suited for this is a broadcast receiver. Okay? So that's these three summed up together help us to implement taking advantage of proximity based applications. And indeed, you will see the example in the lab next time. How does this work in practice? In order to implement proximity alert support, again, you need to get the location manager, and then you create a pending intent. And in the pending intent, you create something called get broadcast method, and then you create a broadcast receiver to be triggered when the pending intent created is fired. And then you create an intent filter and register the receiver to be triggered. And then you add the proximity alert to the specific point of interest. So now you see what you will be expecting in the MTR Stations Alert example that I showed you last time. So basically, the application is driven by making use of proximity alerts in practice. Okay? As an example, this is an intent. You all know how to create an intent, right? If you need to create a pending intent, you would create a pending intent like this. Okay? Once you create a pending intent like this, you can specify to the location managers as follows. Location manager add proximity alert, destination latitude and longitude, and then if you're within 1,000 meters of that location, if you're within 1 kilometer radius of that location, then you fire off this intent. So this is what a pending intent is. So that intent will be fired when certain conditions are satisfied. That's what a pending intent is about.
What are the zeros and the negative?
Well, you need to look up the documentation. For the moment, just put zeros there. But they have certain purpose. Okay, you need to look up the document. I don't remember off the top of my head what it is, but in the documentation it is very clear what it is. Okay, I know this one is the radius around the point, and then these two are, of course, the latitude and longitude information about the destination that I will supply, and so on. Okay, now, having said this, let me illustrate the pending intent example that we saw last time. I'll also show you how I make use of it within the application. And then we'll finish at the point for today. So, Getting back to my example that I was showing last time, which was MTR Station Alert. Last time you saw that it didn't work correctly, but there was a minor mistake in the code and I fixed it. One of the statements needed me to specify something, and then I didn't do it correctly, so I managed to fix it, and it should work fine. It works fine because I know it tested yesterday. Now, how does this work? Getting back to the example, which is the MTR Station Alert, what do I do in this case? In this case, let me close these. I have implemented two versions of it, one without maps, a second one with a maps interface. So you get two different kinds for this example. So that's why I can illustrate to you saying maps and location are two separate things. In this particular case, my example just uses only location information. And we already saw the DB adapter last time, so I'm not going to go into that in more detail. Let me go into this MTR alert activity and then go through this briefly. Now, this is an activity. Obviously, this activity controls what is shown on the screen. And this is the activity that enables me to select the MTR station at which I want the alert to be satisfied. So what I do is, within this activity, in the onCreate lifecycle method of this activity, I call location manager. Okay. How? Location manager gets system service, location service, as you've seen. Now, what I do is, I realize that I need certain features for my location to be supported for my location manager. So what I do is I take this location manager and then enclose it inside a private class that I declare, a singleton class that I declare in Java, and then I send the reference into the location manager, because inside there I provide other methods that make it more easy for me to set up the location management. So this my location manager is the one that I implement as a singleton class. You will see this here. The my location manager is the singleton class which I implement, where I keep track of my location, and inside of this I provide methods like, for example, set location manager, which allows me to request for location updates. So what I do is I enclose all the other methods that I'm using on the location manager inside a single class, so that it makes it easy for my code to be read. So you do realize that even though I write code, I don't want to write sloppy code. So I write code which is more easy to manage. So inside here, this is where I take care of, once I get the location manager's reference, this is where I register to receive updates of the user's location. So I say location manager, request location updates, location manager, GPS provider. So I am asking for fine location for the user. And then this one specifies the minimum time between updates. So in this case, I'm specifying the minimum time between updates, which is 1000 milliseconds. So every second I want an update to be delivered to me. Okay, which is very, very resource consuming, but you can change this value to make it less resource intensive and so on. So and then minimum distance change for update. If the distance between the 2 points has changed by this much amount of time, then please update me. So some of the zeros that you saw, those are the values that I specified. If you specify -1, which means that I don't care about distance, update me every certain units of time. And then this one helps me to add the proximity alert for my application. So I say add proximity alert. So what I have done is I have created a separate method inside my class and then put that proximity alert in there. So unfortunately, I'm running out of time, so I have to stop at this point. Let me just briefly show you what I have here. So this is the screen that you will see. This is the activity that is created by the screen. So let me set up a proximity alert for this station. And what I will do is I will trigger the proximity alert so that we'll see what happens when the proximity alert is triggered. So this is 114. This particular application that we have seen last time is going to be triggered when we call the function. So as I showed you last time, we can make use of, let's see. So within this, if you are making use of an emulator, now obviously location information is determined by the device, right? So it's a property of the device. So if I set up a proximity alert, for example, for a particular location, obviously if I have a real device, I will have to physically go to that location in order to test it. Now, when you're developing an application, if you, for example, you set up a proximity alert to Kuntong MTR station, you can't keep going all the time to Kuntong MTR station just to test your application. So within Android, if you are using the emulator, you have a mechanism whereby you can supply GPS information, or what we call as fake GPS information to the device. Even to a real device, you can set it up to receive fake GPS information, and then you can push the GPS information to a real device also in order to carry out tests. Now, within Android, the way with the emulator, the way you would send GPS information to the emulator is by using this thing called as emulator control. Okay, this emulator control is a very useful method of sending information to the emulator. Like, for example, if you want to make a call to your device in order to test how it behaves when it receives a call. So you can make use of this in order to send the latitude and longitude information to your device. So down below here, you can type in the latitude and longitude information and send it to your device. So let me just send this information to my device, and then you notice this thing up there. That is basically indicating, that is a notification to the device saying location for this device has been set. So I have set it to a particular location. Let me set up a proximity alert on this, say to this MTR station here. So this is 114.2193. Let me try with something close by 22.31. Okay. Now, what happens if I send this information to the device? So, the moment I send this information to the device, I'll be able to see at the bottom. You saw that the distance was popped up using a toast message down there. Okay, that essentially gives you an approximate estimate of the distance from the actual location to where this device is at this moment. So that's another property that I have implemented in the application. Now, let me send the exact location, and then we'll see what happens when this device is triggered. So 2193 and then 3155. If everything goes well, you should be able to. Did you hear the alert sound? So basically, this is informing my device saying that it has reached that particular location, and this information is also triggered by delivering an alert which as a broadcast to my device, a notification alert to my device. So in this application, I also make use of notifications. So that's one more thing that you will encounter in this particular application. So this is informing you that you are near that location, and then so that's something that will be interesting for us to see. Okay. Now, all this is implemented in the different. Again, the code is fairly straightforward, implemented in 3 or 4 files here. Now, the database, we have already examined the database in one of our earlier classes, so I'm not going to go into details of that. Now, what I will do is, I will show you the main activity which triggers this particular application. One more feature is that in this particular application, I made use of a spinner widget on the screen. So it allows me to select the location appropriately. So as you can see, I have set up the location manager here, and then I fill in the data here using, this is all querying the database in order to get the information. And once a station is selected, then what happens is that when the station is selected, I get the information about the station, the latitude and longitude of the station. And then after I get that, what I do is I add a proximity alert to that particular location by calling this function. This function I have implemented as part of the my location manager class, which I have implemented separately within this particular application, as you will see tomorrow. So in this application, what I have done is I have implemented all aspects of managing the location-based information into a single class so that it's easy for me to deal with it. So what I have done is I have implemented it as a singleton class here, my location manager. Within this class, I have implemented several features. Now, this allows me to set the location, and then this is where I set up my location manager, and then I register this particular function, request location updates. Do you remember last time I mentioned about this function called request location updates? If you call this function and register, you are informing the framework saying, periodically update me when the location of the device changes. So that's the part of the information there. And then this is the other function, the add proximity alert. So this is the function that I use to set up the proximity alert. I supply the station and the latitude and longitude information here. And so in here, I create an intent, and then I turn it into a pending intent, as you see here, and then register the pending intent as a get broadcast here, and then I add proximity alert for using the location manager. So this is the function that I use in order to set up the location manager with the latitude and longitude information supplied here. The third parameter is the radius around the point within which I will consider the proximity alert, and I supply the proximity intent here. So this is what causes the intent to get fired within my application. Okay, and also you saw that every time I receive an update on the device's location, I will print out information on the screen specifying how far I am from the actual location that I'm trying to reach. And this is done by using this particular function called as my location listener. Location listener is a listener that you can implement, which will be triggered whenever there is an update of the location delivered by the Android framework to you. Last class I mentioned about it. So in here, I am implementing this function called onLocationChanged. So when is this function going to be called? Whenever there is a change of location, this function is going to be called. And then when this function is called, I am basically printing out this information on the screen. So this is how I'm printing out every time there is a change of location of my device, and I get an update on my location for the device. I'll print out this information saying I am this much distance away from my destination. But this has nothing to do with proximity alert. This is yet another function of how you can make use of the location information in order to trigger certain things to be implemented or to be displayed on the screen. This is the proximity alert part. Now, when this proximity alert, when this pending intent is fired, I need a broadcast receiver to be implemented. So this is the implementation of the broadcast receiver. So to implement the broadcast receiver, what I am doing is I am subclassing the broadcast receiver class, and then in here I implement. See, remember that for a broadcast receiver, there is only one lifecycle method to be implemented, which is the onReceive method. So this method will be triggered whenever a broadcast is delivered to this application. So when this method is called, I check for information to see whether I am nearing a particular location, and after that I print out. I am sending a notification to the notification bar informing the user saying, hey, you have reached the location. You have reached very close to the location that you intended to. So for that, I get hold of notification manager. The notification manager is the one that allows me to deliver notifications to the notification bar of my device. So here, I will create how do you deliver a notification to the notification bar? I create an intent and then create a notification and then deliver this information there. So that is what causes this proximity alert information to be triggered onto the screen that you saw earlier. I think that is gone already because I've clicked on it. Okay? And then this is the function that creates the notification. There is some explanation in here about how to do it, but you will see more details about it in the lab tomorrow on how to actually make use of it in practice. Okay? In addition, also, this is what triggers the sound to be produced. Remember, when the device reaches near that location, you heard a sound being produced by the device, and this is how I produce the sound on the device. So I specify the sound, saying when that notification is triggered, make this sound. So that is how I can make it produce the sound. And you can even cause, this one is used to trigger the, if your device has an LED built into the browser, like what you see here. This is a trackball in a device. Some devices have them. If you have a trackball, what happens is if you need to deliver an alert, you can flash this LED, and this is what is used to flash the LED. So three different parts in there to implement how to create a notification. So in case you want to create notifications in your applications, make use of that as a template for your application. Okay? Any questions?
What's that bar?
Sorry. This one? This is language. Or and or not that you do in your in C or C++ or something like that. This is the same thing in Android also, or in Java also. You are ORing this particular flag into the set of flags. Bitwise ORing, bitwise ANDing. Remember, where you taught this bitwise ORing and ANDing in C++ somewhere? It's the same thing. This is the Java way of doing this. Okay. Then obviously I should not be teaching what you are supposed to be doing. Okay, any other questions? Alright? Again, it's a quick overview. Tomorrow, go to the lab and do the exercise and then you'll understand. Now, getting back to the application, one more feature that is supported is called as geocoding and reverse geocoding. This is again related to location, but quite useful. Geocoding and reverse geocoding. What is this useful for? Geocoding and reverse geocoding helps you to translate an address into a latitude and longitude information, and reverse geocoding helps you to do the reverse. Now, where is this useful? Suppose you know the address of a building. You want to be able to implement an application that triggers some alert when you reach a particular building, and you want to know the address of that building. Obviously, for us to be able to work with latitude and longitude pieces of information is very cumbersome for a user. Instead, how do humans refer to a location? We always specify a location based on the address. You would say 101 Winglock Street, Sangwon. That is very clear to us. But for a computer, the latitude and longitude position information is a lot more useful. So how do you translate from a physical address into a latitude and longitude information? And vice versa. Given a latitude and longitude, can you find the corresponding approximate address of that location? And this is what geocoding and reverse geocoding is very useful. Now obviously this goes together with maps. Obviously it makes sense because you want to be able to point to a particular location in the map and be able to find out what its latitude and longitude are and so on. So that's the purpose of this function called geocoding and reverse geocoding. So in case you are making use of this within your application, this is one thing that is very useful. And this is provided by these two particular classes called geocoder and address within Android. Okay. So the idea is as follows. Given a latitude and longitude, can you get the corresponding address of the location? Here is a piece of code to illustrate to you how you can do reverse geocoding in this particular example. So in this case, what we are doing is we are getting the latitude and longitude information of a particular location. Say, for example, you have a object called as mloc, which stores the latitude and longitude of a particular location. You query that object and then get the latitude and longitude and then supply it to this particular function call. What is this? This is nothing but a object of type geocode. So when you do that, if you supply the latitude and longitude information to that and then supply it, then it will return an object of the type addresses. And this addresses is nothing but a string. And from that, you deconstruct and then get hold of the string, and then you can print the string out on the screen. Now this querying is sent to, in case of Android, it is sent to Google's geocoder and reverse geocoding support. So you send for example, a latitude and longitude, and then ask the query, and then it will send back the address of the location. You send the address of a location, it will send you back the latitude and longitude of that particular location. And this is very useful for certain applications. Now, we personally have made use of this particular information very effectively in a couple of applications that we implemented, where we needed to we allow the user to point at a location on a map, on a map interface, and then from the location that the user points out, we automatically deduce the latitude and longitude of the location, and then make use of that information to carry out some interesting functionality. So this is very useful. In geocoding, say for example, suppose you have an address like this. Suppose somebody tells you an address like this. In that case, you would create a geocoded object here, and then you would put the address in there, and then do a query on the address, and from there you will be returned a piece of information which contains. This is an object of type addresses, but this in this case will contain the latitude and longitude information within the reply, and from that you extract the latitude and longitude information and can print it out on the screen. So this is yet another usage of geocoding and reverse geocoding. Again, goes together with locations and the maps, which I will talk about in the next. Okay. So, does everybody approximately understand what geocoding and reverse geocoding is? Primary idea: translate an address into its latitude and longitude, and reverse: translate the given latitude and longitude information of a point to guess the approximate address of that location. That's the purpose behind it.